Hi, my name's Chris LaShore, and I'm the AP Physics 1 teacher here at Manchester High School, and I'd like to welcome you to the 2020 academic school year. I'm going to tell you a little bit about myself. I have a background in biochemistry and psychology, with a master's in secondary education. While at school, I was the university's tutor for both algebra-based and calculus-based physics. I also tutored physical chemistry and thermodynamics, and a host of other science-related classes. I'm a husband and proud father of two beautiful daughters, Susan on the left and Emma on the right. Susan is now a 9th grader at South Windsor High School, and Emma has just begun kindergarten. We're going through the same challenges as you, navigating a hybrid and remote schedule. I know how frustrating things can be at times, so I'm certainly empathetic toward everything that we all are going through. I want to take a moment to just talk about AP Physics in general. AP Physics is unlike any other class. If you're interested in learning about my course as a whole, just physics in general, I encourage you to go back and watch one of my other presentations found on the same spreadsheet you accessed to this video. Either look in the honors or CP classes. You'll see exactly what this course is about. But I'm going to take a time just to talk about this course in particular. It's very important when students register for AP Physics that they know why they're taking the class, that they're here for a purpose. Those purposes that I consider good reasons are those students that want to go into the medical field or are interested in medicine. They may want to go on to get a major in a physical science or go into engineering. Sometimes students just want a rigorous challenge. This is the best challenge the College Board offers, and arguably the hardest challenge at Manchester High School. Sometimes students just have a passion for physics, and they want to deepen their understanding of the natural world. This course can do that. Being here and having a reason to be here and to work hard, finding that intrinsic motivation to do well, is so important in AP Physics 1. This is a bear of a course with astronomically high failure rates around the world. When students hit a wall, they have to find their own reasons from within to push through that. If they don't have a good reason to take this class, they might struggle. They might fall behind. They might not reach out to get help, and eventually they might give up. We want to make sure that every student in this course comes in here with a positive attitude, are willing to put in the work it takes to earn college credit, and not give up in the face of difficulty. A word of caution about this class. A lot of students do take AP Physics because they're trying to earn college credit to get exempt from physics in college. Well, AP Physics 1 is an algebra-based physics course. There's no prerequisites to take the class. However, I encourage students to have a solid foundation in algebra, and it's really encouraged that they've at least taken geometry and algebra 2 to get the most out of the course and to be able to keep up with the extremely fast pace the College Board has set. Students who've progressed further in their math classes typically tend to do better, and it's not because they know more math. It's just they've been practicing those math skills for much longer than other students, so they're naturally just more comfortable with those common skills. The difficulty of the math in this course isn't much. In fact, you'll hear people say that students who take the AP exam in May won't pick up their calculator even once. This is not a course about mathematics. This is a course about developing concepts and arguing from evidence. While we do rely heavily on principles of mathematics, and we apply those principles to situations, at the end of the day, we're not doing anything more than basic algebra, things students have been doing since 7th, 8th, and 9th grade. It is completely accessible to all students. It just takes work to take abstract concepts they've seen in the past in math courses and now apply them in a science classroom. We need to make sure that any student who plans on majoring with a bachelor's in physical science or engineering, they need to not expect to earn college credit for this class, even if they pass the AP test. Most universities that a student would go to for those majors would require them to take a calculus-based physics course. This is an algebra-based physics course. Those universities wouldn't accept this as transferable credit. So if that's a factor in your child's decision on taking this class, make sure they know that this course most likely won't give them the college credit. Now, if you're going into a biology or life science, something where physics is required, but not through a quantitative science lens, talking about the life sciences, you're probably going to be okay with this class. Most universities do accept AP Physics 1 as a replacement for their introductory algebra-based physics course at the university. So students can earn college credit as long as they're going into the right programs that will accept it. I encourage students to look ahead to see the colleges they're interested in and see if this class will count. But regardless of earning college credit, this class is foundational to doing well in college and every aspect of life. The course focuses on problem solving and critical thinking, skills that are necessary to be successful. Right? Going into college with a foundation of physics, regardless of what level of physics you take at college, will allow the students to do better as the course material becomes more difficult. At the college level, you'll have to already have a firm understanding of these concepts as you start working with solving problems using computational strategies. While there's not a huge emphasis on the computational component of physics in this course, we still do ask students to do it so they get practice, but they'll see it much more in college. We take the approach of concepts before calculations. We develop our concepts thoroughly so that when it's time to calculate, the math just becomes a natural extension of our new learning that we founded in class. So let's talk about the bear in the room, the AP Physics test. These are last year's data numbers, right? So, well, not last year. I have 2018 up on the board. What you see here is an astronomical number. It's astonishing. 45.4%. That's the number of students in the world last year that passed the AP Physics 1 test, all right? Technically, that data is, well, that is 2019 data. That number doesn't really change. AP Physics 1 has been going on for 6 years now, and that number is pretty locked in place. It means, on average, about 55% of students that take this test in May, who are taking this class right now, won't end up passing the exam in May. If you look at the numbers over on the right that are circled in red, the sample size of students that took the test in 2018 was 170,000 plus. That number is about the same each year. Of those 170,000, only 5.7% passed the test with a score of a 5, and only 15% with a 4. Those two numbers, 4 and a 5, that's how you earn college credit. We're talking about just more than 20% earned college credit out of all the students who took the class in the world. When my students enter this door, I tell them not to set their expectations there. Getting a 3 on the AP Physics test is such an accomplishment. And even though you might not earn credit, you're doing yourself a huge service by studying it now, risk-free, learning the language of physics so that when it matters most in college, you can be successful. Even looking at those numbers, it's staggering to see how many students don't pass this test. They can work all year and do all the assignments, do every single lab, and still fall short. It's common. With that said, last year, we still had 3 students get 5s on the AP Physics test and 4 students get 4. In fact, our pass rate for last year's cohort, 24 students, we had more than 70% of our students pass the test with a 3 or higher. We beat Connecticut's national average. We beat the world's national average. We are doing amazing things at Manchester High School. I can't take credit for it. Our students are so well prepared. They're coming in ready to tackle this. I give them opportunities to develop those experiences, critical thinking and problem solving. I teach them strategies. But at the end of the day, the onus is on them to pick up that ball and keep running. They have to practice, practice, practice to pass this test. This may be the first time your son or daughter doesn't get an A on the report card. It may be the first time they fail a test. These are tough lessons to learn, but ones that are better learned in high school than in college. If a student expects perfection of themselves, they're always going to come up disappointed here. If you look at 2018's data, the one where only 5.7% of the students passed the test. If you ask the students in my class, how many do you think got a perfect score? They always come up with some number. The real answer? 3. Only 3 students out of the entire world last year got a perfect score on the AP Physics test. It's just not an attainable goal. It's not reasonable. I ask my students to go in here with an open mind, to expect the challenge, to expect to fail some things, but to always learn from their mistakes. So with that said, what does it mean to even get a 5 or a 4? Let's take a look. A 5, which we saw only 5.7% of the world did, In order to score a 5, which universities think is a perfect score, right? Perfect in the sense that you've demonstrated a mastery of physics. A student in May can earn a 5 on the AP test with a 71%. Meaning they can, that's traditionally what? A C- in high school. They could get a 71 on the test and still get a 5 and earn that college credit. Look at the value for a 4. The cutoff for a 4? 55%. You can fail the test numerically based on traditional high school values. And based on this cutoff here, 55% or higher, up to 71, would still earn you 4 and earn you college credit. In fact, students can earn a 3 and still technically pass the AP Physics test. Not with college credit, but still pass by only earning 41% of the available points. When my students see this for the first time, typically after their first assessment, it helps ease some of their anxiety. They see that, wow, this must be a hard class. This isn't just Manchester, it's not just me, it's not just my teacher. This is something that I'm going to have to work hard for, and I can't expect perfection. I think it's important for all of us to identify that this class is a challenge, that everyone, regardless of where you're at, struggles, and we have to work together to bring our numbers up and to help students fill in the 3, 4, and 5 category, because I know they can do it. Real quick about the class. The whole first quarter is devoted to kinematics. We study linear motion, constant velocity, average velocity, motion diagrams, taking data from a motion dot diagram and putting it onto a position time graph, looking at velocity time graphs, using skills from math to analyze velocity time, acceleration time, and position time graphs, the significance of a slope, what these terms mean, how they're different from everyday language. We spend the quarter developing the foundational skills and vocabulary to allow us to be successful later in the year. The whole course, for the most part, is mechanics. We talk about linear motion, and then we talk about projectile motion. We deal with dynamics, forces, and Newton's laws and accelerations. We talk about momentum through the lens of Newton's third law. We deal with circular motion and gravitation. We then talk about the law of conservation energy and apply the work-energy theorem to explain things we observe in mechanics. In second semester, we deal with torques and rotations and simple harmonic motion and oscillators. Finally, we move away from mechanics and deal with waves and sound, DC circuits, and electric charge. This is a lot of material to cover in a very short amount of time that's even shorter now thanks to the pandemic. We want this curriculum to be accessible to all students, so we make sure that we focus on concepts before calculations. We give lots of time to practice. At the AP level, it's about 60% mathematical, computational, hard work, and 40% concept building and developing skills through skill practice. Right? We want our students to be critical thinkers, problem solvers, and good collaborators. That's why a company will hire you. A company will hire you for the human element. They want you to do what a computer can't. Computers can compute computational things, right? They crunch numbers. When you get hired by a company, they want your brain. How can you take what you know about the world and solve a novel problem? How can you look at the constraining factors of a situation or the initial conditions and come up with a solution that a computer just couldn't? They want you to be critical thinkers and problem solvers. They want you to be able to take your ideas and communicate them well to other teams of people that might not speak the same language of science you do. You have to find the right language so everyone understands what you're trying to say. These are the things we work on every day in my class. We ask questions, we do modeling. We construct explanations, we plan investigations. All of this is super important. Grading rationale, 15% of the grade comes from skills practice. That's practice, practice, practice. That's how we get better at critical thinking and problem solving. It's risk-free. Everything's graded for completion. Lab grades. Lab grades are virtual labs, in-person labs, things that get at the underpinnings of science, the scientific method, analyzing data, making evidence-based claims from data. How can we sort through disinformation, fake news? How can we look at that stuff and say, I know what is true based on evidence, and I can justify my claims based on the evidence. That's the things that we try and do now. Assessments are 60% of the grade. They make up of mid-unit summatives and other short check for understandings, pop quizzes, reading checks. The whole gamut keeps students on their toes. Assessments can be made up. This growth mindset model, I have to be quick now, I have 30 seconds left. It is really the idea that students learn from their mistakes. I give them opportunities to reflect and revise and earn points back. No student needs to fail this class if they're willing to put the effort in. And I really show them that by giving them fair and honest attempts to go back and review their work, to go back and make those corrections and show me they've learned the material, right? Extra help is always available from 2:45 to 3:45 each day through a Google Meet. It's always helpful for students. I'm out of time, so thank you very much. If you have any questions, please email me. Have a wonderful day.